In this video, we're going to solve 2004 Form B Question 2 FRQ. So it says, for 0 is less than or equal to t, which is less than or equal to 31. The rate of change in the number of mosquitoes on Tropical Island at time t days is modeled by r of t equals 5 root t cosine t divided by 5 mosquitoes per day. There are 1,000 mosquitoes on Tropical Island at t equals 0. So let me underline that. That part's important. That's the initial amount. Show that the number of mosquitoes is increasing at time t equals 6. So if you plug this into the rate formula, if it's greater than 0, it's increasing. If it's less than 0, it's decreasing. So for part A, r of 6, plug that into your calculator. When I plugged it in, I got 4.438, which is greater than 0. So the number of mosquitoes, mosquitoes, is increasing. Okay, part B. At time t equals 6, is the number of mosquitoes increasing at an increasing rate, or is the number of mosquitoes increasing at a decreasing rate? Give an answer to your answer. Give a reason for your answer. So that's pretty easy. You would take the acceleration formula. So you take the derivative of r of 6 and see what the sign is. So when you use your calculator, you will get negative 1.913, which is less than 0. So it's not speeding up in the direction that it was originally moving in, because if you look at these signs, they alternate. So this is increasing at a decreasing rate. Okay, part C. According to the model, how many mosquitoes will be on the island at t equals 31? Round your answer to the nearest whole number. So when you solve this, you have to account for the initial 1,000. So you do 1,000 plus the antiderivative of 0 to 31, r of t dt, which will give you about 964.335. So 964 mosquitoes. Okay, so far so easy. Part D. To the nearest whole number, what is the maximum number of mosquitoes for 0, which is less than or equal to t, which is less than or equal to 31? Show the analysis that leads to your conclusion. Okay, my recommendation is to graph the rate function. So what I did is I actually graphed it and I put it on decimals. So this is a rate function. This is r of t dt, this function over here. And I also pointed out where it has the critical points, which is at 5 pi over 2 over 0 or 15 pi over 2 over 0. Now, one thing that I want to point out is this part of the graph is above the x-axis, so it's increasing then decreasing. So this is a max. This is a min. Okay, let's go back to our other graph. So now I'm going to minimize this. And now let's say, for whatever reason, you didn't graph it or you weren't sure. You would have to set the rate function to 0. So 5 root t cosine t divided by 5 equals 0. So when you do this, you'd get cosine of t over 5 equals 0. Where is that going to occur? Well, here's the graph of cosine. This is pi over 2, and this is 3 pi over 2. But since you have this 5 over here, you'd have to make the numerator 5 times larger. So it'd be 5 pi over 2, or 3 pi over 2, and that's not 15 pi over 2, I'm sorry, which is not the same exact graph, but it kind of gives you a gist of how to solve it. Okay, so anyway, going back, so now we have to integrate, and I'll prove it analytically as well. So we know 1000 plus 0 to 0 r of t dt is equal to 1000. This question asks us for the maximum number. Okay, so that's a contender. We know 1000 plus 0 to 31 r of t dt is equal to the 964. That's not it. So now we have also 1000 plus 0 to 5 pi over 2 r of t dt, which gives you, I should put the dt over here, dt, which gives you, when I solved it, 1039.357, so 1039 mosquitoes. Okay, that looks like it is it. We know it is it according to our graph, but now let's say you really want to check the 15 pi over 2. So you put the 15 pi over 2, and you need the 1000 out here, plus r of t dt, and I already know this is a min because if you looked at your graph, there was a ton of negative area. And this actually equals 842.405, so it's definitely not it. So this question says, how many mosquitoes to the nearest whole number? It'd be 1039. That would be your maximum. And I hope this video helped.